Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the 2022 chemistry examination. Now, we analyze the question and answer of spectroscopic techniques such as infrared spectroscopy, nuclear magnetic resonance spectroscopy, and mass spectrometry. These techniques are applied to analyze the structure of organic compounds. Spectroscopic techniques are the most difficult section in VCE chemistry. But this section is my favorite, and I organize a few simple skills to answer these questions. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Number of signs is the first information of NMR. Here, we can count 5 signs. 5 signs suggest that 5 different carbon environments. However, B has 6 carbon environments and is eliminated first. There is a single peak at 140 parts per million, and 110 to 140 parts per million belongs to carbon-carbon double bonds. In the A, C, and D, only D has carbon-carbon double bonds, so D is the correct answer. When we read NMR, please focus on the high ppm because function groups always appear in high ppm. From the data book, we know that the chemical shift of carboxylic acid or ester is located around 170 parts per million. The ketone is located between 205 and 220. So, this compound is not ketone but carboxylic acid or ester. 2 marks cover 2 points. 1 point is awarded to the correct answer and another reason. The narrow and deep valley is found at 1,700, but on broad valley appears between 2,500 and 3,500 and is the specific hallmark of carboxylic acids. So, this compound is not carboxylic acids but ester. Both carboxylic acids and ester contain a carbon-oxygen double bond, but ester lacks of hydroxide group. The ratio of peaks at 108 to 110 is 3:1, so the compound must contain chlorine because the abundance of chloride 35 is 3 times of chlorine 37. The peak at 110 is due to the chlorine 37. Both peaks at 108 and 110 are parent ions. Since the relative molar mass is a weighted average of these two parent ions, the molecular mass of molecule J is not a whole number. 2 singlet peaks give 3 pieces of information, 2 different chemical environments, they isolated each other, and the ratio of the hydrogen in the 2 environments is 2 to 3. If any points are written, a student could get 2 marks. If this ester does not contain chlorine, the molecular formula can be expressed as CnH2NO2. This ester contains 1 chlorine, so its molecular formula is expressed as CnH2n1O2Cl. Substitute the atomic mass of carbon, hydrogen, oxygen, and chlorine into the equation of molecular mass, and solve this equation. The number of carbon is 3 and write the molecular formula. When we calculate the molecular mass of the organic compound, please use the whole number and neglect the decimal point. The atomic mass of chlorine is 35 because the molecular mass is 108 which contains chlorine 35. The peak at 4.1 parts per million represents 2 hydrogens linked to carbon-chlorine, and the peak at 3.8 parts per million represents 3 hydrogens in methyl that is linked to the ester group. So, this compound is methyl 2-chloroacetate. Please draw all bonds because the structure formula is asked. There is 1 multiple choice question worth 1 point. There is also 1 short answer question worth a total of 10 marks in this section. The overall score for spectroscopic techniques is 11 points. With a total possible score of 120 points, the percentage for this section is 9.1% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Chemistry channel.